Okay, good morning, all the students.
Good morning, ma'am.
Confirm whether you can see the presentation.
Yes, ma'am.
Right. Okay, in the last class, we have seen various kinds of granularity of backup, taking the backup. So we take the backup, organizations can take the backup as a whole, means full backup can be taken. Otherwise, they can take a incremental backup, and other type of taking the backup is cumulative backup. Now I have a question for you. First answer this so that we can proceed with the other topics. Tell me which kind of backup will utilize less storage space? Whether it is a full backup or an incremental backup or cumulative backup. Which backup will take lesser storage space? Which backup will consume lesser storage space? Like in classrooms, you don't have books to refer, right? Arbaz? Devmalia?
Yes, ma'am.
Yeah, try to answer this question.
Yes, ma'am.
Which kind of backup consumes lesser storage space in whether it is a full backup, an incremental backup, or cumulative backup? Asta?
Yes, ma'am.
What kind of backup utilizes less space? Sunil? Pavitra? Are you all there? Sneha? Speak out. Srinivas?
Ma'am, I guess cumulative backup.
Cumulative backup will utilize lesser space. Cumulative backup will take each previous day's backup. It keeps on accumulating all the updations, and then by the end, it will take the backup of all the day's updations on one day, and that day's data can be restored. Because it takes or accumulates all the day's updations, it will actually occupy more storage space. Out of all the backups, full backup will take more storage, because every time backup is taken, not only the updations that are made, but the entire backup, even the old files backup as well as the newly added data backup also have to be taken. So it is quite obvious, right? Whenever you take full backup, it will occupy complete more amount of storage space. Then comes the incremental backup, cumulative backup. After cumulative backup, oh, I asked lesser space, right? My question is, which occupies lesser space or more space? What is the question I asked?
Less space.
Lesser space. Lesser space is incremental backup, and more space is full backup. Cumulative backup occupies moderate space. Okay, so because in incremental backup, only the updations that are made to the repository are taken as backup. That is why it occupies the less space, it occupies less storage space, whereas full backup occupies more storage space. In the middle, cumulative occupies a moderate storage space. Now another question, in which kind of backup restoration will be faster? Based on my previous question, you can take it as a reference to answer this question. Which kind of backup will provide quick restoration in case of a disaster. Ginger?
Incremental backup.
Incremental backup takes quick, gives us quick restoration. Any other answer? Srinivas?
It's full backup, ma'am. It's full
Which
backup.
kind of
Full backup.
backup? Huh? Quick restoration, quick restoration. Cumulative backup. It is cumulative backup because cumulative backup on the previous day, say when a failure occurs on Sunday, then till Saturday, all the previous days backup are accumulated onto one single day, that is on Saturday. So it is just enough to restore the data from the Saturday's backup. So that will provide us quick restoration. Whereas in incremental backup, every day's incremental backup separate. The backups are not accumulated, they are separately taken. So whenever a failure occurs on Sunday, all the days backups have to be taken one after the other to restore. So it takes more time. The full backup as well as cumulative backup. A full backup also takes more time to restore because it has to restore the entire databases backup or entire repositories backup have to be restored. So it will take too much time. But in cumulative backup, already there is a full backup that is available. So that need not be touched at all. But any changes made after that is accumulated into one day's backup, and whenever you're restoring it, it is just enough to restore the previous day's backup, which actually reflects all the previous days backup. All the weekdays backup will be available on Saturday. So taking a Saturday's backup will be enough on Sunday to restore the lost data. Okay, so it is very quick to restore in cumulative backup, and it takes long time to restore in full backup. Incremental backup again takes a moderate time to restore. So what is the hierarchy that we found? While talking about the storage space occupied, the storage space occupied by full backup is more. After that, cumulative backup occupies more space, storage space. After that comes the incremental backup. Okay, so if you take like this inverted pyramid, then it will be easier to understand. Now you can say here full backup will take more storage space. Cumulative backup stores consumes lesser storage space, and incremental backup still lesser storage space. But when we take the restoration time, in that case, full backup will take more time to restore. This is with respect to time. Okay, in this case, full backup will take more time to restore, then incremental backup will take lesser time than full backup, but more time than cumulative backup. Finally, cumulative backup will take the least time to restore because it is just enough to take one day's backup, which has accumulation of all the previous days backup. Did you understand now? I'm stressing more on this backup granularity because it is an important question. Are you able to understand? Ginger? Srinivas? Now it is clear?
Yes, ma'am.
Yes, ma'am.
Okay, now let us go to the next topic, backup and restoration operations. Now, when a backup operation is initiated, significant network communication takes place between different components of the backup infrastructure. So what are the components of backup infrastructure we have seen in the last class? The client, backup server, and the network, right? So whenever a file's backup has to be taken, that backup request either can be initiated by the client, or sometimes the server itself will have the schedule to take the backup. Accordingly, the backup will be taken. Now, whenever the backup operation is started, then significant network communication means lots of data have to be passed, communicated over the network in order between different components of the backup infrastructure, between the client nodes and the backup server nodes. Lots of data have to be transferred in order to perform the backup process. Now, the backup operation is typically initiated by a server, but it can also be initiated by a client. In some cases, backup operations, if it is scheduled and planned and it is handed over to the server, then every now and then, frequent intervals, it will schedule the backup and runs the backup operation. But sometimes even the client can also request for taking the backup. Now, the backup server initiates the backup process for different clients based on the backup schedule configured for them. That is what I have told you right now. Backup server will initiate the backup activity for different clients that are connected with it based on the backup schedule that is configured for that particular client. Say client 1, the backup schedule is every 1 hour. For client 2, the data generated by client 2, the backup schedule is every 24 hours. For client 3, every weekly the backup has to be taken. Based on the schedule that is configured for that particular client, the backup server will run the backup task. For example, the backup for a group of clients may be scheduled to start at 11 p.m. every day. Sometimes the clients can be grouped together, and for all of them, one single backup schedule can be executed. Here the example is, say if the backup has to start at 11 p.m. every day. Means after all the business operations are completed, after the business hours of the organization, around 11 p.m. the backup has to be taken for a group of clients. Like that, the backup can be scheduled. Now, the backup server coordinates the backup process with all the components in a backup environment. So, in the backup environment, what are all the components that are involved? All these components will be coordinated with each other by being monitored by the backup server. So backup server will be responsible to coordinate the backup process, entire backup process, by harnessing all the components in the backup environment. Backup server acts as a coordinator to enable smooth backup activity, to perform the backup process by coordinating between all the components in the backup environment. Now, the backup server maintains the information about backup clients to be backed up and storage nodes to be used in a backup operation. So, what should be available with the backup server? In yesterday's class, we have seen that backup server will maintain two files, two components. Sorry, not components, two kinds of information. Backup server will maintain two kinds of information, that is the backup configuration and the backup metadata. Do you remember? Now, the backup server maintains the backup configuration information about the backup clients to be backed up and which storage nodes have to be used in the backup operation. Okay, all this information will be kept in the configuration file. Now, the backup server retrieves the backup related information from the backup catalog and based on this information instructs the storage nodes, means the storage arrays, to load the appropriate backup media into the backup devices. So this configuration file, this backup catalog, will have the information of what is the frequency of the backup, which data have to be used, which data backup have to be taken, and on which media the backup has to be taken. So this kind of information will be kept in the backup catalog, because some kinds of data may be stored on a tape drive, Some kinds of backup can be taken on a disk. Some kinds of data can be remotely, asynchronously or synchronously transferred to a remote site based on the recovery point objective. Recovery point objective, if it is very long, means the organization can afford to lose data for a longer extent. In that cases, they have sufficient time to restore also. In such cases, the backup can be taken on tape drive, which requires a significant amount of time to restore. Right? In such cases, if the data is not too critical, then the backup media can be tape drive. But if you want quicker restoration, the RPO, recovery point objective, is much smaller. The data have to be frequently taken for backup. In that case, the backup media can be selected as a disk. But in other cases where the recovery point objective is very, very small, near zero recovery point objective, in such cases, the backup can be asynchronously or synchronously transferred to a remote site. Okay, that is how that information will be kept with the backup catalog. Now, simultaneously, it instructs the backup clients to gather the data to be backed up and send it over the network to the assigned storage nodes. So what are the storage nodes that are assigned to take the backup and keep the backup copies? That will be sent over the network by the backup server to backup clients. Now, after the backup data is sent to the storage node, the client sends some backup metadata to the backup server, because the metadata of the backed up data to be stored with the backup server. Once the backup data is sent to the storage node, immediately the client sends back some metadata about the data that has to be backed up to the backup server so that it will save it in the metadata file. Now the storage node receives the client data, organizes it, and sends it to the backup device. So what are the other tasks of storage node? It receives the client data, yes, it organizes the client data and sends it to the backup device where the backup copy have to be stored. Now the storage node then sends additional backup metadata. What about the additional backup metadata? What kind of data it may take as metadata? Location of the data on the backup device, time when the backup is taken, and such kind of information will be stored as additional backup metadata that will be sent as additional backup metadata to the backup server. So this is sent by the storage nodes. Storage nodes can interact with the clients in order to send this data through clients to the server. Now the backup server updates the backup catalog with this information. The backup catalog requires this information because the backup catalog should have the information of when the last backup is taken and on which device, on which backup device that backup copy is stored. All that information is required as additional information to be stored in the backup catalog. So that is sent by the storage nodes to the backup server. Now this is how the backup operation takes place. It is very clear to understand from this picture how the backup operation takes place. As the initial step, the backup server initiates scheduled backup process. Remember, the backup processes can be scheduled. When they are scheduled to be executed either 1 hour or 2 hours or per day or weekly, that schedule, based on that schedule, the backup server initiates scheduled backup process. And as the second step, the backup server retrieves backup related information from the backup catalog. Only then it will know where to store the backup copy on which target, whether it can be a tape drive or a magnetic disk or a remote site. Based on the type of the backup target, the backup server to know the backup target, the backup server retrieves backup related information from the backup catalog. Now after that, the backup server instructs, see this operation represents the backup server instructing storage node to load the backup media in the backup device. So this is the backup device. In this case, we take a storage. Again, backup device is a storage array where the backup copies are stored same as the original data is stored, right? So this step says that the backup server instructs the storage node. This is the storage node. The storage node to load the backup media, whether it is a tape library or whether it is a magnetic disk, load that backup media in the backup device. So this backup device will now be ready with its loaded media to take the backup copy. Now, the third 3B step, backup server instructs backup clients to send data to be backed up to the storage node. So backup server will act as a mediator to communicate with the storage node and backup device, and at the same time it can also communicate with the backup clients to get the data for which the backup has to be taken. So as a third step, second part of third step, it will contact the backup clients or application servers to send the data for which the backup has to be taken, and communicates it to the storage node. Now, as a fourth step, you can see the fourth step here. As a fourth step, backup clients send data to the storage node and update the backup catalog on the backup server. So the data for which the backup should be taken is sent to the storage node, and at the same time, the backup catalog also will be updated near the backup server. Now, as fifth step, the storage node sends data to the backup device where the backup media is ready to take that copy. Okay, so the storage node, after it sends the data to the backup device, as a sixth step, storage node sends the metadata and media information to backup server. So where this backup data is saved, what is the location where the backup copy is saved for this particular data, that information along with the media information will be sent as additional information back to the backup server by the storage node. Okay, and after that, the backup server updates the backup catalog, and that is end of the backup operation. Right? So when the backup server initiates the backup task, it notifies the storage node, and it also notifies the backup device to load the backup medium, and at the same time it requests the backup clients to send the data for which backup has to be taken to the storage nodes. Now the storage nodes saves the backup copy on the appropriate backup media and sends that additional metadata back to the backup server and completes the task of backup operation. Is it clear how the backup is taken? Pavitra? Sneha, is it clear? Ravi Shankar? Are you all there in the class?
Yes, ma'am.
Yes, ma'am.
Okay, now let us see further what happens with this restoration operation. Okay, how the backup is taken with the backup media we have seen. Now how the restoration process happens means whenever a disk failure or a system failure or in case of a disaster at the data center, how the data can be restored. After the data is backed up, it can be restored whenever it is required. So a restore process must be manually initiated from the client. So whenever there is a disaster and the original data is lost, then the client may request to restore the lost data to the and send that request to the backup server, right? So a restore process must be manually initiated from the client. Now, some backup software has a separate application for restore operations. In some cases, there is software which operates separately for taking the backup and separately for the restore operations. But in some software, both can be combined together. Now, these restore applications are usually accessible only to the administrators or the backup operators, because restore operation is again costly and sometimes it is confidential also. These restore applications are usually accessible only to the administrators or the backup operators only. Now, upon receiving a restore request, an administrator opens the restore application to view the list of clients that have been backed up. Okay, so what is the first step? Whenever the administrator receives a restore request from the client, then it will open the restore application to see what are all the clients where the backup copies are available. It will view the list of clients that have been backed up. Now, while selecting the client for which a restore request has been made, the administrator also needs to identify the client that will receive the restore data. Okay, now the client, while selecting the client for which a restore request has been made, means a client will initiate the restore request, right? So it will identify whether that client is an authorized client which is requesting for the restore operation, and is the restore operation does the restore operation really needs execution? Means if the data is really lost, that will be validated, only then the restore operation will start its activity. Now, the administrator also needs to identify the client which will receive the restore data, which will receive the restored data. Okay, so the client who requested for the restore operation and the client which will receive the restore data, both have to be identified by the administrator. Now the data can be restored on the same client for whom the restore request has been made, or it can be restored to a different client also. And the administrator then selects the data to be restored and the specified point in time to which the data has to be restored based on the recovery point objective. So which data have to be restored and to which checkpoint it has to be restored will be selected by the administrator. To which checkpoint means whether it is last 1 day's data or last 1 hour data or last 10 minutes data. The recovery point objective is 6 hours, then up to 6 hours data till the last checkpoint, means till 6 hours previously the data have been saved by having a checkpoint. Now after that the 6 hours data has been lost. So it has to recover the data up to that checkpoint. That will be decided by the recovery point objective, to which checkpoint the data have to be restored. And because all this information comes from the backup catalog, the restore application needs to communicate with the backup server also. So the communication during a restore operation doesn't happen only between administrator and the backup client, administrator and the restoration client, but it also have to consult the backup server in order to get the information from the backup catalog, because the restoration operation requires the information from the backup catalog also. Now the backup server instructs the appropriate storage node to mount the specific backup media onto the backup device. So the backup server will ask the storage node to mount where the backup copy is saved on the tape drive or disk. Load that backup media onto the storage node so that the copy can be restored from that media. Okay, so data is then read and sent to the client that has been identified to receive the restored data. Now, once the backup media is loaded onto the loaded for access by the storage node, then the storage node reads the data and sends the data to the client that has been identified to receive the restored data. Now, some restorations are successfully accomplished by recovering only the requested production data. So whatever is the requested production data, only that may be restored. But in some cases, additional operations have to be performed. I'll tell you what are those operations. Let us see, for example, the recovery process of a spreadsheet is completed when the specific file is restored. So if the backup client requests for, not the backup client, if a client requests for some recovery of a spreadsheet, means an Excel sheet. In such cases, that Excel sheet is passed to the client, and that is the end of the restoration operation. But in other cases, along with restoring the data, it has to perform some additional operations. In database restorations, for example, additional data such as log files must be restored along with the production data. This ensures consistency of the restored data. So what will be there in the log files? Say uncommitted data, unsaved data that is temporarily stored in the log files may have to be handed over to the database in order to preserve the data consistency. So in database restorations, additional data like log files must be restored along with the actual data. Now this is to ensure the consistency of the data that has been restored to the client. Now in these cases, the recovery time objective is extended due to the additional steps in restoration operation. What is recovery time objective? Can anyone answer for this? Recovery point objective is how much data loss a business or organization can afford. Now, what is recovery time objective? Ravi Shankar?
Yes, ma'am.
What is recovery time objective?
Ma'am, it's amount of real time of business.
I couldn't hear you.
Ma'am, it's
Can you-
like amount of real time business, ma'am.
What is that? Real-time business. You were not there in the class yesterday.
No, ma'am, I was there, ma'am.
Then how many times I repeated on these two concepts, recovery point objective and recovery time objective? Srinivas? Can you answer this? What is recovery time objective? Asta?
Yes, ma'am.
What is RTO? Recovery time objective is the time a business can afford, the downtime a business can afford. Means the time before which the lost data can be restored. The time between the failure and the time till which the operations can be restored. The duration between this is called as recovery time objective. The time, the downtime, the duration of time, downtime a business can afford is called as recovery time objective. Before recovering from the disaster, how much time a business can afford? That is called as recovery time objective. Now, in these cases, the recovery time objective is extended due to additional steps in the restoration process. So, when a restoration operation is being executed, then recovery time objective can be extended due to this kind of additional operations like loading the log files and restoring them along with the production data or the actual data. Now, this is how restoration operation takes place. In this case, the application server or the backup client requests the backup server for restoring the lost data or corrupted data. Now, in the as a second step, the backup server scans the backup catalog to identify the data to be restored and the client that will receive the data. So not only the backup catalog is scanned to not only identify the data that has to be restored, but also the client who will receive that restored data, because that authentication, validation have to be made so that it will not restore the data to a wrong client. Okay. Then as the third step, the backup server instructs the storage node to load the backup media in the backup device from which the backup copy can be restored. So this storage node will indicate the backup device to load the storage media. Then as a fourth step, the data is read and sent to the backup client. Means it is read from the backup media where the backup copy is available, and that data is sent to the backup client. Now that is further sent to the backup server. The storage node sends the restored metadata to the backup server. Now the backup server will update the backup catalog once it receives the restored data, and also sends it to the backup client, which actually asked for the restoration of this data. Okay, so the backup client requests for the backup server for data restore, and the backup server instructs the storage node in order to load the storage media where the backup copy is available. And once the backup copy is read by the storage media, it is sent along with the metadata to the backup server, and the backup server will serve that information, that restoration information, to the backup client which requested for that data that has to be restored. Now there are different topologies that are implemented in this backup. Another important question in this chapter, backup topologies. There are 3 backup topologies that are used in a backup environment. They are direct attached backup, where the backup is saved on a direct attached medium, or it can be a LAN-based backup where the data that has to be backed up is sent over a LAN to store the backup copy, or it utilizes the SAN medium in order to save the backup, to send the data and save the backup. Now, a mixed topology is also used by combining LAN-based and SAN-based topologies. Now let us see what is direct attached backup, how direct attached backup is taken. Now the storage node is configured on a backup client, and the backup device is attached directly to the client. In this case, where the direct attached medium is used for backup, the storage node is configured on a backup client itself directly. So where the client requests for a backup, even the storage node where the backup copy is saved is also mounted on the client itself, and the backup device is attached directly to the client. That is what I said. The backup device where the backup copy have to be stored is attached directly to the client itself. Now only the metadata is sent to the backup server through the LAN. Say if the backup server is at a distant location, first the backup copy is stored on the backup client itself, and its metadata is communicated to the backup server over the local area network. Now this configuration frees the LAN from backup traffic. So this one advantage of this kind of configuration, this kind of implementation will free the LAN from backup traffic. Means the data for which the backup have to be taken need not be transferred over the network to and fro. Only the metadata can be transferred, and the original backup data can be saved on the same client where the backup request is made. Now the backup device is directly attached and dedicated to the backup client. Yes, because it is a direct attached storage. It is dedicated to the backup client itself. Now, as the environment grows, there will be a need for centralized management and sharing of backup devices to optimize the cost. Now, it is very costly to have a dedicated storage with every backup client. In such cases, as the environment grows, as more devices plug in, and as the backup requirements keep on increasing, as the backup requirements keep on expanding with respect to the amounts of data that has to be stored within an organization, in such cases, there will be a need for centralized management and sharing of backup devices to optimize the cost, so that they can share the backup devices across all the backup clients. For that, an appropriate solution is required to share the backup devices among multiple servers in the architecture. For that, network-based topologies like LAN-based and SAN-based provide the solution to optimize the utilization of backup devices. So because of the limitations of this direct attached backup, slowly the technology have evolved into LAN-based backup and then further to SAN-based backup. Now this is the representation of a direct attached backup. In this case, you can see the backup client here. This is an application server or a storage node, or it acts as a backup client. Now, the backup device here is directly attached over this solid line. This solid line indicates the direct attachment. This direct attached storage is dedicated to the backup client itself to store the backup data. And the metadata about the backed up data have to be saved with the backup server on the backup catalog, and that only that information will be transferred over the local area network to the backup server to store that metadata about the backed up data. This is how a direct attached backup is taken in this architecture. Now, when we go to LAN-based backup, that is because of the limitations of this direct attached backup, then it evolved into LAN-based backup. In this LAN-based backup, the client's backup server, storage node, and the backup device are all connected to the local area network. So they are not directly connected, but because of this LAN connection, because of these devices connecting over the LAN, the backup storage media can be shared by other clients and servers also. Now the data to be backed up is transferred from the backup client, that is the source, where the data to be backed up is generated, to the backup device, that is the destination, over the LAN. So the data has to be transferred from backup client to the destination, that is the backup device, over the LAN connection, which might affect the network performance, because already on the network, lots of data communications, data access takes place. Now, again, in addition to that, if you're also transferring the data for backup, that will affect the network performance. Now, this impact can be minimized by adopting a number of measures, such as configuring separate networks for backup and installing dedicated storage nodes for some application servers. So what is the alternative? In order to reduce this adverse effect on the network performance, you can either use different networks for transferring only the backing data. So if data that have to be backed up, if you want to send them over the network, better use dedicated networks only to send the data that have to be backed up. Or you can install some dedicated storage nodes for the application server, so that it need not consume any network bandwidth while taking the backup and storing the backup copies. Now, this is how a LAN-based architecture, LAN-based backup architecture looks like. In this case, the application server or the backup client, which generates the data for which backup has to be taken, and the storage node, which initiates the backup process, the backup device, where actually the backup has to be stored, backup copy has to be stored, and the backup server, which stores the data about the backup catalog, which stores the metadata about the data that has been backed up. All these will be at distant locations, and they are all connected together over the LAN network, right? These architectures are very simple to understand. To present in exam also, it is easy for you. Just see what are the advantages of each architecture and disadvantages, and how the next evolving technology, advancements in the technology, have overcome the drawbacks and brought new features for execution of that process. Here it is the backup process. Okay, so all these components here are connected over the LAN, and the backup data can be transferred over this LAN to the backup device, and the metadata can be transferred to the backup server over the same LAN itself. Here you can see the connections are indicated by this narrow line, and the transfer of data is indicated by this dotted line. Not dotted line, the line, this staggering line, you can see, right? That will indicate the transfer of data. Whereas this solid line indicates the connections between the devices, and this dotted line indicates the metadata that is being passed. Now comes the SAN-based backup. Still, there are some limitations with LAN-based backup where network performance will always be a bottleneck if more amount of backup data have to be transferred over the network. Then that has evolved to overcome the drawback, the architectures have evolved into SAN-based backup. Now, in this SAN-based backup, it is also called as LAN-free backup because it is not being limited by the LAN network. There is no limitations that are posed by the LAN network. That is why they are sometimes called as LAN-free backup. Now, the SAN-based backup topology is the most appropriate solution when a backup device needs to be shared among the clients. So, if the backup device have to be shared by multiple clients, in such cases, SAN-based backup topology is the most appropriate solution to enable that sharing between the backup clients at the same time without having to encounter any network bottlenecks. Now, in this case, the backup device and clients are attached to the SAN directly, storage area network directly, where fiber channel communication is used. Now, a client sends the data to be backed up to the backup device over the SAN rather than using LAN. Here they are using the SAN architecture. Therefore, the backup data traffic is restricted to the SAN and only the backup metadata is transported over the LAN. Because the backup metadata is lesser, that can be transferred over LAN, whereas the backup data for which the backup has to be taken, that can utilize the SAN in order to maintain some difference between the traffics. The metadata traffic can be transferred over lesser capable LAN and greater traffic, more traffic is sent over the SAN, which is more capable of holding large amounts of data communication. Now, the volume of data, metadata is insignificant when compared to the production data. So the LAN performance is not degraded in this configuration. So in this kind of configuration, where the metadata is passed over LAN and the data traffic is passed over SAN, the LAN performance is not degraded because it contains only, it transfers only less amount of metadata over the network. Now, this is how a SAN-based backup architecture looks like. In this case, the backup server is connected over LAN to the backup client where it receives the metadata from the backup client. Now, at the same time, this backup client is connected to the backup device over FC SAN and also it is connected to the storage node over FC SAN itself, so that it can send all the data for which the backup copies have to be taken and stored on the backup device and notified to the storage node. All this happens over FC SAN where large data traffic is supported when compared to LAN. Now, when we come to mixed topology, combination of this topology, the mixed topology uses both LAN-based and SAN-based topologies. This topology might be implemented for several reasons, maybe including reducing the cost, depending on the server location, reduction in administrative overhead, and performance consideration. Taking all these aspects into consideration, sometimes the storage providers may use combination of this backup topologies. Here you can see a mixed topology where the backup server over the LAN is connected to the backup clients, two different backup clients to receive the metadata, to update the backup catalog, and at the same time it is connected to the storage node also. And this backup client over the FC SAN, it will be connected to the backup device. In this case, multiple backup clients are connected over LAN to backup server and over SAN to backup device. This is called as mixed topology. It is utilizing the mixture of LAN-based and SAN-based backup in order to enable the sharing of these networks between multiple backup clients. Now let us see how the backup is used, how the backup is performed in NAS environments. We already know that network attached storages are mainly used for file transfers rather than serving application requests. If you want to use an architecture which is dedicated for file transfer, then we use network attached storage. Okay, that has been made very much clear to you in module 3 and 4, right? So how the backup is taken in NAS environments, where NAS is specialized to transfer only files rather than serving application requirements. In this case, the use of a NAS head imposes a new set of considerations on taking the backup and recovery strategies in the NAS environments. So NAS heads use a proprietary operating system. We know that there will be a specialized operating system that is used by NAS heads in order to perform the file transfer. Now, NAS heads use a proprietary operating system and file system structure that supports multiple file sharing protocols. It may use ISCSI, it may use FCIP, it may use SCSI, it may use FTP. Different kinds of file transfer protocols may be used by these NAS heads. So they have some specialized operating systems in order to execute multiple file sharing protocols. Now in the NAS environment, backups can be implemented in different ways. One way it is called as server-based backup, and the other way it can be called as serverless backup, and the other type is network data management protocol. Now, common implementations of network data management protocol are again two-way NDMP and three-way NDMP. Now, we are going to see how the backup is taken with respect to these different kinds of implementations. Now, in an application server-based backup, the NAS head retrieves data from a storage array over the network and transfers it to the backup client running on the application server. This is called as server-based backup because the backup client running on the application server gets the data directly from the NAS head. Means the NAS head will be used to retrieve the data from the storage array over the network and gets it transferred to the backup client, which is actually running on the application server. Now the backup client sends this data to the storage node, which in turn writes the data to the backup device. So the backup client sends this data that is received from the NAS head through a storage array that is received from the backup client to the storage node, which in turn writes the data to the backup device to store the backup copy. Now this results in overloading the network with the backup data and using application server resources to move the backup data. Right? This becomes an overhead in the network because along with the backup data, the application server resources are also utilized in order to move the backup data in server-based backups. So how the server-based backup is exactly executed? In this case, the application server or the backup client is connected to a network attached storage head. Now this network attached storage heads have operating systems to execute various file transfer protocols. Now this network attached head is connected to the backup client over the LAN and at the same time to the storage node also. And on the other end, they are connected to the backup devices and the storage arrays over the FC SAN. Now, in this case, the servers, the LAN will be overloaded with the resource utilization that is utilized to send the backup data from the backup client to the NAS devices, NAS heads. But this can be overcome in a serverless backup. In a serverless backup, the network share is mounted directly to the storage node. Rather than via a server, now the network share is mounted directly to the storage node in case of a serverless backup. Now, this avoids overloading the network during the backup process and eliminates the need to use resources on the application server. You know that application servers will be busy serving the requests of the clients. Now, if you're overloading it with the backup task also, then more resource utilization will actually degrade the performance of application server. That is why, in order to avoid this, serverless backup can be taken. In serverless backup, overloading the network can be avoided during the backup process, and it also eliminates the need to use the resources on the application server, so that application server can retain its IO performance by serving the application request from the clients itself. Now, in this scenario, the storage node, which is also a backup client, reads the data from the NAS head and writes it to the backup device without involving the application server. Here, the storage node, sometimes which is also a backup client, reads the data directly from the NAS head and writes it to the backup device without having to bring into the communication any application servers. So application server resources can be utilized only for the sake of serving the requests of application clients. So compared to the previous solution, this eliminates one network hop. How is that? Before, in server-based backups, every communication have to go via the server. But in this case, because of the absence of server, because of not including the server, that via server hop can be avoided. So this kind of communication eliminates one network hop and saves the time in taking the backup. Now that is how we are using here. In this case, you can see the dotted line, how the data is being transferred. In this case, the data is being transferred via the application server. But in a serverless NAS, the data is not going here to the server. It is just going through the LAN, through NAS head, through the storage device, and being saved on the backup device without involving the application server in this process of taking the backup, right? That will reduce one network hop going till here and coming back. That network hop can be avoided and time of taking the backup can be reduced in this serverless backup. Now, when we go to NDMP backup, NDMP is an industry-based TCP/IP-based protocol specifically designed for a backup in a NAS environment. So this is specialized backup process that can be done in the NAS environment. It communicates with several elements in the backup environment, such as NAS head, the backup devices, backup server, backup clients, storage node. All the elements in the backup will communicate with each other for data transfer, and it enables, this NDMP enables vendors to use a common protocol for the backup architecture. Rather than NAS head using one protocol, backup clients using one protocol, backup server using one protocol, because of the implementation of this NDMP, it will help the vendors to use a common protocol for coordinating between all these components in the backup architecture. Now, the data can be backed up using NDMP regardless of the operating system or the platform on which different devices are running in this architecture. Due to this flexibility that is provided, it is no longer necessary to transport the data through the application server, which reduces the load on the application server and also improves the backup speed, and time taken for backup can be reduced. Now, NDMP also optimizes backup and restore by leveraging the high-speed connection between the backup devices and the NAS head. Because of the high-speed connections that are implemented between the backup devices and the NAS head, it can also optimize the backup, means backup can be quickly taken and the restoration also can be quickly done, which will reduce the recovery time objective of any business. Now, in NDMPs, backup data is sent directly from the NAS head to the backup device, whereas metadata is sent to the backup server. So in this kind of implementation, backup data can be directly sent to the NAS head so that it can be sent to the NAS head of the backup device so that it can be directly communicated, whereas the metadata is sent to the backup server over this NDMP. Now in the NAS environment using NDMP with a two-way connection, network traffic is minimized by isolating data movement from the NAS head to the locally attached backup device. So the network traffic can be reduced by isolating the data movement from the NAS head to the locally attached backup device, because there is two-way communication. You can divide the data that is being transferred over the network. Now only the metadata is transported over the network, but the actual backup data can be directly connected to the NAS head and transported to the backup device. Now the backup device is dedicated to the NAS device, and hence this method does not support centralized management of all backup devices. So only one drawback with this kind of implementation is the backup device, though it is dedicated to the NAS device, this method does not support centralized management of all backup devices because it is having direct attached NAS devices for each of the backup clients. Now this is how an NDMP two-way NAS environment looks like. Here the backup server, the backup client or the application server is connected to the backup server over this NAS head, over the LAN. And this application server over the LAN, it is connected to the backup server and to the NAS head directly, which is connected to the backup device, and over FC-SAN, it is connected to storage array. Here, application server is not in any way included in the communication, which will actually increase the backup and restoration, which will actually reduce the backup and restoration time. Now in three-way backup, a separate private backup network must be established between NAS heads and the NAS head connected to the backup device. Metadata and NDMP control data are still transferred across the public network. So only metadata and the NDMP control data can be transferred over public network, and all the backup data can be transferred over the private network. That is the importance of three-way NDMP data. It enables the NAS head to control the backup device and share it with other NAS heads by receiving the backup data through the NDMP. And this is how NDMP three-way NAS environment looks like. Here the backup client and the backup server, though they are connected over LAN to pass the metadata, but connected to the NAS heads in order to communicate with the storage array to send the backup data over FC-SAN. So metadata is sent over LAN and backup data is sent over SAN through the private network. So public network can be used only to send the metadata, and private network can be used to send the backup data, which will create a clear demarcation between the utilization of the networks so that the optimization of the network utilization can be achieved. And we also have some backup targets to be considered, where the backup target can be a tape drive if the RPO and RTO is larger, and it can be backup can be taken on a disk drive if the RPO and RTO are moderate, and backup can be taken to a virtual tape if the RPO and RTO are smaller. Virtual tape means all the tape libraries are integrated, and virtual memory is provided, virtual storage memory is provided in order to store the data virtually on the virtual tapes. So if RPO and RTO is too large, you can go for backup tapes. Moderate, you can go for backup taken to disks. And if the RPO and RTO of an organization is very small, they can't afford any data loss or they can't afford any downtime, in such cases, they can go for backup taken to virtual tapes, where it can be mounted quickly in order to restore the data that has been lost. Okay, students? Do you have any doubts? If at all I have gone little faster, you just go through the recording once again, you'll be able to understand the concepts. So one more concept is left out. Let me see when I can schedule the class for you to finish that concept also. That is local replication. Very easy concept to understand. That will finish in one more class. That will be the end of our module 5 and also the end of syllabus. Okay. So I'll meet you in the next class. Before that, I'll take attendance.